One of the founder of the modern astronomy, German astronomer, Johannes Kepler is best known for his law on planetary motion. First two laws were published in 1609. Later, in 1619, he added the third law. We are to discuss here all these three laws of planetary motion in real-time 3D animation. These three laws are applicable for all planets, or planet-like celestial bodies, that orbit the Sun, or Sun-like object.
First law says, the orbit of a planet is an ellipse, with the Sun at one of the two focal points. Before this law, astronomers around the world believed that the planetary orbits were circular, which has another small circle on its perimeter.
This small circle is called an epicycle, as described in the law of Nicolaus Copernicus. In Copernicus' model, the Sun resides at the center of the circular orbit, while planet stays on the perimeter of a small circle that revolve around the Sun. This small circle is called epicycle. And this is how planet changes their distance from the Sun. You can trace the actual trajectory, or orbit of the planet. Note that, it is not a circle.
Kepler's first law completely replaced the circular orbit with an elliptical orbit. It says, planetary orbit is an ellipse. And the Sun stays on a focal point. Hence, the planet's distance from the Sun is not constant. It has lowest and highest values. The point, on the orbit, that is closest to the Sun, is called perihelion, while the most distant point on the orbit is aphelion. The second planetary law says, a line segment, joining a planet and the Sun, sweeps out equal areas, during equal intervals of time. Suppose, radius of this planetary orbit, while orbiting the Sun, swept this area in 10 days. And then, move here, and swept this area, in another 10 days. According to Kepler's second law, these two areas are equal. Thus, you can see, to sweep equal areas, a planet needs to run faster near the Sun, and requires a slower motion when it is far away from the Sun. In reality, astronomers observed that every planet goes slow when it is farther away from the Sun, and goes fast when it comes closer to the Sun. Earth's orbital speed at perihelion is 30.3 km per second. But it is 29.3 km per second at aphelion. Orbit of comets are very elliptic. Hence, it goes far away from the Sun and goes slowly there. Spends many years there. But once it comes closer to the Sun it runs faster. Thus it stays a few weeks here. Halley's comet runs at 54 km per second near the Sun, but it goes slower, at nearly 1 km per second at aphelion. Third law of planetary motion says, the square of a planet's orbital period is proportional to the cube of the length of the semi-major axis of its orbit. C. Diameter of a circle is equal in every possible direction. But for an ellipse, it is not true. An ellipse has a variable diameter. The shortest diameter is called minor axis, and the longest diameter is known as the major axis.
Half of major axis is called a semi-major axis. According to Kepler's third law, planet's orbital period square varies proportionally with the cube of its orbital semi-major axis, or t square proportional to the r cube, where t is the time that the planet takes to complete a revolution around the Sun, and r is the semi-major axis of its orbit. This relationship was later derived by Sir Isaac Newton by using law of gravitation. Hope you realized the topic and understood it clearly. Like and subscribe to this channel to watch more such videos.